Good morning, pre-calculus trig class. Today is Wednesday. Happy Wednesday, hump day. We are directly in the middle of week 1 of our 3-week shutdown as mandated by the governor of Michigan. Anyway, I hope you guys are keeping busy, trying to keep yourself sane in your homes. Here's a look at what I've been doing. Got a little puzzle action going on here. You can see it is the Michigan Stadium, the big house. Here's a picture. It's a very difficult puzzle. This is what we're looking at here. See all the yellow, actually all the maize. But we are going to move on. I'm going to construct some YouTube lessons for chapter 8. I'm going to continue on with some trig, in particular applications involving right triangles, SOHCAHTOA. Some of you have asked about some things that you can do while you're just sitting around. I took that survey a couple days ago regarding the location of your book, and every person except one said that their book was at home. So again, this is totally optional, not mandatory. It's not going to be graded, but it's just going to be something to keep you smart and keep you busy. So take a minute to pause the video, go get your notebooks, and we're going to do some example problems, 3 example problems from chapter 8-1, and then we'll be ready to roll. So here's the beginning of 8-1, right triangle applications. We have 2 learning targets. I can find the values of all 6 trig functions in a right triangle, and I can solve right triangles. Feel free to pause the video at any time that you want to, so that you can write some things down. So pause the video at this moment too. I just wanted to give you the 6 trig functions in basic form. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and so on. A fair warning, your book does call these sides A, B, C, where C is the hypotenuse and A and B are your legs, but it virtually is the identical version of what I have here. So for example 1, what I'd like for you to do is to find all 6 trig functions based on the angle theta. And if I give you a little triangle here, it looks something like this. Most of the time you're going to have 3 values. In this case, I'm going to give you 8 and 5. Right? Normally we're going to call the hypotenuse C, and then the legs can be A and B. So what we need to find is move this up a little bit. We need to find sine of my angle theta, cosine of my angle theta. All right. Now, we also need a theta, and my theta is going to be down here in this angle. So I have to find the 6 trig functions, which means I need to have all 3 sides found. I want to use the Pythagorean theorem in order to find that missing side right over here, which is going to be A. So let's say that A squared plus 5 squared is equal to 8 squared, which means A squared plus 25 is equal to 64, which means A squared is equal to 39. And if I take the square root of both sides like this, that means my A value, that means my A value is going to be the square root of 39. All right, so we can label this over here square root of 39, and now we're just going to plug all of our values into this. So sine of my angle theta is opposite over hypotenuse. Opposite is across the triangle, which is 5, and divide that by hypotenuse is going to be 8. So sine of my angle theta is 5/8. Automatically, we know from our reciprocal identity that cosecant is the reciprocal of sine, so cosecant is 8/5. Cosine is adjacent over hypotenuse. Adjacent to my angle theta is the one right next to it. That's not the hypotenuse, and let's call that root 39. And let's put that over the hypotenuse, which is just 8. Again, if I take the reciprocal of that, 8 over root 39, that gives me secant. The problem is that we have a root in the denominator, and that's not allowed. So let's rationalize by multiplying it by itself over itself. So on the top, I have 8 root 39, and on the bottom, I have just 39, which cannot be reduced. Tangent is... Oops, I made a mistake over here. These two, this is secant theta, and this is cotangent. Props to you if you noticed that before I fixed it. But tangent is opposite over adjacent, so opposite is going to be 5, and my adjacent is 39, so let's call this 5 over root 39. Now, before you rationalize, take this and take the reciprocal of that right away. So now I don't have to rationalize my cotangent, which is going to be root 39 over 5. And now I can rationalize my tangent and call this 5 root 39 over 39. So we found all 6 trig functions of my angle theta, and there they are. We can go from there. A couple of cool examples involving the cofunction identities. If you have your identity sheet, which unfortunately I do not have mine. For example, here's one of them. Sine of my angle theta is equal to cosine of 90 minus my angle theta. There are 6 versions of these involving sine cosine, cosine sine, secant cosecant, cosecant secant, and then tangent cotangent, cotangent tangent. They're all the same. They all look like this. Some versions may have a pi over 2 if we're talking about radians. So if we kind of keep this in mind when trying to evaluate some of these, and what we want to do here is to find exact values. Find exact values, no calculator allowed. I'll give you 2 examples and we can mess around with some of these here in just a moment. My first example is cosine of 72 degrees minus sine of 18 degrees. So my cofunction identity says, and we can actually use this one that I wrote down here as an example, that sine of an angle is equal to cosine of 90 minus that angle. And so technically what I could do is I can rewrite this as cosine of 90 minus 18, right? Because my cofunction identity says that these are identical to each other. Okay? Now, what I can say is that cosine of 72 minus cosine of 72. And so my final answer here is going to be 0. And my last example of this type is this. Secant of 20 cosecant of 70 minus tangent of 20 cotangent of 70. Right? So now secant and cosecant are cofunctions of each other. And so technically I could write it like this. Secant of 20 times secant of 90 minus 70. We'll simplify that in just a second. Minus tangent of 20 times cotangent of 90 minus 20. I'm falling off the paper here. But the idea here is that I have secant 20, secant 20. And over here on this side, I have tangent 20. This should be a tangent, not a cotangent. What's wrong with me? Tangent 20. So now secant 20 times secant 20, I could write as secant squared of 20. And the same thing here, tangent of 20 times tangent of 20, I can write as tangent squared of 20. Now, what can we do with this? Does this look like anything? Does this look like anything? It looks like one of my identities that says 1 plus tangent squared equals secant squared. Can you visualize if I can take this to the other side and I have secant squared minus tangent squared? Since these angles are the same, since these are both 20 and 20, I can find out that my answer is 1. And for my final example here, let's call this example 3. You have one set of directions, and that is solve the triangle. And the simple directions here is to find all 6 values. That is 3 angles and 3 sides. Most of your triangles are going to look very similar, and all of your triangles will have at least 3 given values. So let's call this ABC. So we have a triangle called ABC, and we have 2 given sides, 4 and 7. Now, we do have 3 given values. We have 2 sides and 1 angle. Here's what you have to remember. If this is angle A, and angles are represented by capital letters, across from that would be side A, and that's represented by a lowercase. This is angle B. Across from that is going to be lowercase b, and here's angle C. That's going to be represented by lowercase c. And so our job is to find, and we're going to make a list here, of all 3 angles, capital A, capital B, capital C, and all 3 sides, lowercase ABC. let's fill in the three things that we know already. First of all, angle C, I know is going to be 90 degrees. Second of all, little a is 7. We can put that here. And little b is going to be 4. We can put that here. We have these two angles here, angle A and angle B, which are related to each other. And we're going to use our calculator in order to figure out what these values are. So in the case of angle A, I know that I have two sides. Opposite is 7 and adjacent is 4. And so that tells me that I need to use tangent. In this case of tangent of angle A is going to be opposite over adjacent, or 7/4. And now what we've learned to find an angle is that we just use inverse of both sides. In this case, inverse tangent of 7/4. Let me grab my calculator. Boom. Magic. All right, so inverse tangent of 7/4. Remember that we're going to represent these in degrees, so let's check the mode. My mode is in radians, so I'm going to move that to degrees. And inverse tangent is second tangent of 7/4. And so angle A is 60 point, let's call that 26. 60.26 degrees. So we can put this up here, 60.26 degrees. Now, one thing that I know is that the three angles of any triangle always add up to 180. I know that this one is automatically 90, so I can subtract angle A from 90 to get angle B, which is going to be 29.74 degrees. All right, so we have one left to go. I'm going to give you two options in order to find lowercase c. You can have your choice. You don't have to use both. I just want to show you both so that you can understand that there are two ways. And the first way is the Pythagorean theorem, a squared plus b squared equals c squared. So little a is 7, so we're going to call this 7 squared plus 4 squared, which is 49 plus 16, which is 65 equals c squared, and so c is the square root of 65. Your book says to round these to the nearest two decimal places, so the square root of 65 is going to be 8.06. Now, a second option is to use trig in order to find this. And notice my hypotenuse is here, okay, from, let's call angle A. Opposite is 7, and hypotenuse is the lowercase c that I'm looking for. Opposite and hypotenuse would indicate sine. So sine of my angle, and sine of angle A, which I already know, is 60.26, right, is equal to opposite over hypotenuse. Now, if I multiply this by c and bring this up here, I can divide by sine of 60.26, which gives me c is 7 divided by sine of 60.26. Let's check this out. Here, let's just do this. 7 divided by sine of 60.26. And again, we got 8.061865.304. And I write all these out to show you something. If you look at these two numbers, they're very, very close. 8.06. This actually gives you something called a round off error. My actual answer is this one here, which was 8.0622577748. But see how we didn't type in 60.2551187 into the calculator. I typed in 60.26, which was my round off. If I use the actual number, now watch this, 7 divided by sine, and what do we have this number as? 60.2551187. Now, very close. This one, square root of 65, is 0.48 or 748, and this one is 749. What we can do to combat that, if I type in inverse tangent of 7/4 and use the answer function on this, I should not get a round off error. So this would be 7 divided by answer. And answer was the 60.26 degrees that we have. No, it's going to be 7 divided by sine of answer, isn't it? Okay, so there we have 8.0622577748, which is the exact same thing as the square root of 65. That's amazing that those are equal. Now, either way, if you round off your error a little bit, if you have round off error, even if you round off to 2 decimal places, it's going to be the same thing in this case. It may not always be that case, so watch out for your round off error. Now, I am going to assign some work. This work is completely and total optional, completely not mandatory, but if you want to find something to do, you look on page 504. We're going to do numbers 9 through 31 odd. I'll give you the odds so that you can check your answers in the back of the book, and then we'll do 39 and 41. There are some story problems that go along with this, 49 and 51. These are the application problems. Listen, we're gonna make it through this together, all right? We got 3 weeks, 2.5 weeks to go until our expected return date of April 13th. It may last longer than that, I'm not sure, but President Trump said that he wanted to get everything back to normal by Easter, which I hope he's right. I hope we can do that so that we can get our lives back to normal. Let me know down in the comments if you have any questions, or send me a remind message if you have any questions on what we learned or anything about the math. I'm also going to be posting a video later today on the 4 answers to the questions that I posted on Saturday. Have a great day. Talk to you soon.